We work with a number of different data types in Python, primitive types such as strings, booleans, integers, and so on, and also complex data types such as dictionaries, lists, tuples, etc. Python gives you built-in ways to convert certain data types to others, such as strings can be converted to numbers, numbers can be converted to strings, lists can be converted to tuples, and so on. Let's start off with a very simple string 1, 2, 3, 4. We know this is a string because it's enclosed in double quotes. We can use the int built-in function in Python to convert this string to an integer. 1, 2, 3, 4 is a valid integer, so this conversion should go through fine. You can now see that the variable int num holds 1, 2, 3, 4 in an integer form. We know this is an integer because there are no quotes around it, either single or double quotes. This string 1, 2, 3, 4 can be converted to a floating point type as well, that is of type decimal. This can be done using the float built-in function. The floating point type is 1, 2, 3, 4, but this time there is a 0.0 indicating that this is a float. What if you try to perform a conversion that is not actually possible? Here we are trying to convert the string. This is not an int to an integer type. This is clearly doesn't make any sense, which is why this is an error in Python. This is a value error. The value error clearly says that invalid literal for int with base 10. The error is a little bit cryptic here, but it's pretty clear that what you passed into the int function is invalid. The reason this error contains a reference to base 10 is because you can have your integers specified in hexadecimal format as well, base 16, binary format, base 2, octal format, base 8, and so on. This particular string that we passed in was not a valid integer in the base 10 format. Similarly, if you try to convert a string to a float, you'll encounter another error. This error clearly says we could not convert the string to float. There are built-in functions to convert integers represented in base 10 format to other formats as well. Here is the hexadecimal value for 56 in base 10. This is the hexadecimal value 0x38. The tuple function takes in a string and converts it to a tuple. The results of this are a little surprising. Individual characters of the string are extracted and they become fields in the tuple. So the tuple contains HELLO exclamation all as separate characters. We've already seen that a list can be converted to a tuple. This list simply becomes a tuple. A tuple is just a list but immutable. You can pass in a string to the list function as well. The list function will once again extract individual characters of a string and create a list. Here is something interesting that you can do in Python. The input argument to a function can be the return value of another function. What does that mean here? Here, the inner list function takes in the string hello and converts it to a list where every character is a separate element in that list. We pass that list, which is returned from the list function, into the tuple function. The list becomes the input argument for the tuple function. And as a result, we have all the characters of the string hello in tuple format. That is the final return value of the tuple function. Python also supports the set data structure. Sets basically remove all duplicates from any list. You might remember studying this in school mathematics. A set contains no duplicates. So a set of the string hello will contain all the characters within hello, but the duplicates have been removed. The set will not contain the extra L. We've converted strings to integers. We can convert integers to strings as well using the str built-in function. Here we have the string 1, 2, 3, 4. It's present in quotes, so you know it's a string. Let's take this chance to practice the if statement that we use to evaluate conditions, which we learned in the previous lecture. Here we take in some user input. The user will type in a number. We have the message enter a number. Once the user types in a number, we want to evaluate whether that number is divisible by 3. We'll use the modulo operator to see whether the remainder is 0. If that condition evaluates to true, we'll say the number is divisible by 3, else we'll print the number is not divisible by 3. Things look good so far. Let's execute this. We enter a number 9 and then we hit enter and we get an error, a type error. Let's debug this. The type error says not all arguments converted during string formatting. So there was a conversion error here. Let's see where that was. And you can see a very helpful arrow pointing to line number 3 in our cell. It's clear that it is our if statement, if user input modulo 3 is equal to 0, is what caused the error. Python tried to perform some kind of conversion under the hood here, and it is this conversion which caused issues. The user input that's available as a return value of the input function is in the form of a string. So the user underscore input variable contains a string, and the modulo operator which we tried to perform does not work on strings. That is the error that we are seeing here. This basically means that when we accept user input, we need to convert that input's type to the type that we want it to be. We need to convert the string to an integer here. This we do using the built-in int function. We assign the converted result to the same variable user underscore input, and now this cell will work just fine. We enter a number 34 and we get the result. The number is not divisible by 3. We fix the conversion error that we encountered previously by converting our string input to an integer. Let's look at some other interesting conversions. A tuple of tuples can be converted to a dictionary. Notice here that we have 3 separate tuples with 2 fields each, A with 1, B with 2, and C with 3, and that is included in an outer tuple. This can be converted to a dictionary. Just pass in this tuple of tuples to the dict function, and the return value is a dictionary. A, B, and C are keys in this dictionary. 1, 2, 3 are values in this dictionary. If you have a variable in Python, there is no way you can tell just by looking at it what type of data it contains, whether it contains a string, integer, floating point, a dictionary, a nested list, whatever. There is no way to tell just by looking at the variable. This is where the type built-in function is useful. This will tell you the type of a particular variable. That the type of the sum underscore stir variable is a string or str. The type of the dictionary variable is a dict. The type of the tuple of tuples variable is a tuple. You guessed it right. The type of the user input variable is an integer. Remember that we converted the string value to an integer and assigned it to user input. So this type is correct. Let's check one last type here. Type of the float underscore num variable is float.